In this lesson, we're going to evaluate an integral of the form integral 1 over x squared plus bx plus c dx. The method we choose will depend on the discriminant b squared minus 4ac. Let's discuss the possible cases and how different scenarios affect our approach for integration. First, let's talk about the discriminant. The discriminant is given by b squared minus 4ac. It determines the nature of the quadratic expression. If the discriminant is greater than 0, the quadratic is reducible and has two distinct real roots. If the discriminant is equal to 0, the quadratic has repeated real roots and is also reducible. If the discriminant is less than 0, the quadratic is irreducible and has complex roots. Let's consider case 1, discriminant greater than 0. In this case, the quadratic can be factored into linear factors. We can use partial fraction decomposition to rewrite the integral with these factors and find the integral by knowing that integrated partial fractions lead us to the natural log of the expressions. Now let's move on to case 2, discriminant equals 0. This case indicates a repeated root. The quadratic can be expressed in the form a times x minus r all squared. The integral can be simplified by letting u equal x minus r in our integral substitution. Finally, let's consider case 3, discriminant less than 0, which is an irreducible quadratic in this case. We complete the square to express our quadratic equation in this form, a times x plus b over a squared minus b squared over a. We can use an arctangent integral rule. To wrap up, we've explored the different approaches to evaluate an integral of the form integral 1 over ax squared plus bx plus c dx, considering the different cases for the discriminant, when it is greater than 0, equal to 0, or less than 0. Each case led to a unique approach using partial fraction decomposition, completing the square, and substitution respectively. With these tools, we're now equipped to determine the antiderivative and evaluate integrals like this one.